The chain rule says that dy dx is equal to dy du times du dx. So this is just like simplifying fractions. Here we've got on the top and the bottom, we've got a du. If we simplify them, we're left with dy dx. And it works for any letters. So if we had dv dt, that's the same as dv dr times dr dt. We can use this chain rule to differentiate a composite function where we've got a function inside another function. So in this first question, we can say 1 plus 2x is a function in a function. And if we call that u, we can say u is 1 plus 2x, which means that y is u cubed. So if we differentiate both of these, we get du dx, which is 2, and we get dy du times by the power, take 1 off the power, 3u squared. So the chain rule says that dy dx is dy du times du dx. So dy dx is 3u squared times 2, which is 6u squared. And u was 1 plus 2x, so we can substitute that back in for u. So we've got 6 times 1 plus 2x squared. So that's using the chain rule for a composite function. There's actually a quicker way of doing it, which I will show you. So 1 plus 2x is our function within a function. We're going to say dy dx. So we're going to times by the power, take 1 off the power for the whole thing. So it's going to be 3 times 1 plus 2x squared, and then times by the bracket differentiated, which is 2. So times 2, so we've got 6 times 1 plus 2x squared. For the second one, again, times by the power, take 1 off the power. So 4 times 2 is 8. Leave the bracket as it is, take 1 off the power, that becomes 3, and times by the bracket differentiated, which is 3. So we've got 24 times 3x minus 1 cubed. And the last one, let's rewrite it as 5x minus 4 to the power of a half. We're going to times by the power, take 1 off the power, and times by the bracket differentiated. So times by the power, leave the bracket as it is, take 1 off the power, and times by the bracket differentiated, which is 5. So we've got 5 halves times 5x minus 4 to the power of minus a half. 3 for you to try. See if you can give them a go. So we've got a function inside the function. So we're going to do times by the power, take 1 off the power, and then times by the bracket differentiated. So dy dx is 2 times 3x plus 5 to the power of 1 times by our bracket differentiated, which is 3. So we've got 6 times 3x plus 5. The second one, times by the power, 3 times 5 minus x to the power of 2, times by the bracket differentiated, so times by the power, take 1 off the power, times by the bracket differentiated, which is negative 1. So we get negative 3 times 5 minus x squared. And the last one, let's rewrite it as 4x plus 3 to the power of negative 1. And then times by the power. Take 1 off the power. And times by the bracket differentiated, which is 4. So it's negative 4 times 4x plus 3 to the power of negative 2. So exactly the same thing if we're using our other notation. And this time we've got some trigonometric and log functions. So f of x is sine x cubed. So it's the same as sine x inside the bracket and then cubed. So we've got our function inside a function. So our gradient function times by the power, take 1 off the power, and then times by the bracket differentiated. Sine x differentiated is cos x. So even better, write it as 3 sine squared x cos x. For b, we've got again a function inside a function. So we're using the chain rule. So we're going to differentiate it as we normally would. So cos x goes to negative sine x. So we negative sine 3x minus 1. And then times by the bracket differentiated, which is 3. So it's negative 3 sine 3x minus 1. And the last one, again, function inside a function. So we have 2 times 2 plus cos 3x, and then times by the bracket differentiated. Cos 3x will differentiate to give negative 3 sine 3x. So we've got negative 6 times 2 plus cos 3x times sine 3x. 3 for you to try, see if you can give them a go. So the first one, we have a function. So we're going to differentiate. So log x goes to 1 over x. It's going to be 1 over sine x times by the bracket differentiated, which is cos x. So we're going to have cos x over sine x, which you could also write as cot x. B, e cos 3x. So e stays the same, but we're going to times by our bracket, our power in this case, differentiated. So it's going to be e cos 3x times by our bracket differentiated, which is negative 3 sine 3x. So negative 3 sine 3x times e cos 3x. And the last one, so let's rewrite it as 4x plus 3 to the power of negative 2 times by the power, take 1 off the power, and then times by the bracket differentiated, which is 4. So we get negative 8 times 4x plus 3 to the power of negative 3. When we have a function that's x equals, we can find dy dx by finding dx dy and then flipping it over. So for the first question, we can say that dx dy, so it's the same as dy dx, but we've switched the x and the y's. So now it's dx dy. So cos 2y differentiated is negative 2 sine 2y. So cos differentiates to negative sine. And then it's a version of the chain rule. We times by the bracket, or in this case the angle differentiated, which is 2. That's dx dy. So we can say dy dx is just 1 over negative 2 sine 2y. And part B, so dx dy is 6y plus 1 times by the power, take 1 off the power. So dy dx is 1 over 6y plus 1. 2 for you to try. See if you can give them a go. So dx dy. So log y is going to give us 1 over y. And y cubed is going to be 3y squared. So dy dx is going to be 1 over that. So 1 over 1 over y plus 3y squared. I don't really want to leave it like that. So I'm going to times top and bottom through by a y. So it's going to be y over 1 plus 3y cubed. So timesing top and bottom by y changes it so I don't have a fraction in the denominator. And part B, so dx dy so 2 sine y, sine goes to cos, so 2 cos y. So dy dx is 1 over 2 cos y.